Alright, I'm going to record the quiz solution to Exam 3 version 2. Give you a little easier function at the start. As the computer did that, it was easy on you. F of x and g of x. F plus g of x, we simply add the two together. There's only one x squared around, so x squared. There's only one x around. And there's a minus 1 and a plus 1 added together gives 0, so there's our solution. F minus g, again only one x squared around. This time we're subtracting the g of x, so we subtract the x, and it's a negative 1 minus another negative 1, so we subtract 2. F times g, well, it does get a little more complicated. Let's go ahead and write out the multiplication over here. X squared minus 1 times x plus 1. First, inside, out, last. So first, x cubed, x squared times x, outside plus x squared, inside minus x, and last minus 1. And there are no similar exponents around, so that's our answer. X cubed plus x squared minus x minus 1. F over g, now it would be acceptable to do x squared minus 1 over x minus 1. Or if you recognize that x squared minus 1 is the multiplication of x minus 1 times x plus 1. And over x minus 1, well, x minus 1's factor out, so that becomes x plus 1. And just to be super careful, you could say, well, x not equal to 1, because then you'd have 0 divided by 0. But we let that divide out and just put x plus 1. Pretty easy solution. Let's go on to the next one. Here we're going to do find the answer from the graph. Well, we're doing the value of the function at 2, so let's find f of 2. F of 2, here's our 2 as our input, and our output is 3. F of 2 equals 3. F of 2, or g of 2 now, here's our 2 as our input. Our output is also 3. G of 2 is also equal to 3. So f minus g of 2 gives us 3 minus 3, or 0. Now we want f times g of 0. Remember, fg0 is the same as f of 0 times g of 0. Oh, and I forgot that I should have showed you in showing the work up here. F minus g of 2 is the same as f of 2 minus g of 2. Forgot to go through that step. So we have to find f of 0 and g of 0. Well, that just means what's the value of f when x is 0? Well, I get 4. What's the value of g when x is 0? I get 0. So f of 0 is equal to 4. G of 0 is equal to 0. And when you multiply them together, you get 4 times 0, or 0. Coming out to be pretty easy so far. Now, let's do this one here. What do we need to do? Calculate f of g of 0. Well, since 0 is an easy one to calculate usually, let's just find what g of 0 is. G of 0 is equal to, well, when I put a 0 in for x, I get 7. Now I need f of g of 0. That means f of 7. Well, when I put a 7 here for x, it's 4 times 7 plus 5, or 28 plus 5 equals 33. So f of g of 0 is 33. G of f of 0. Well, we need to find what that is first, and then we'll put that inside of a g. So f of 0 is equal to 4 times 0 plus 5, or 5. And now we need g of f of 0 is g of 5 is equal to, well, 7 minus 5 squared. 7 minus 5 squared, or 7 minus 25, or negative 18. And now we use our table to find the various values. We always find the inside value first. So g of 1, from our table, g of 1 is 7. And now we need f of g of 1, which is f of 7. Now f input of 7 gives us 6. G of f of 7, again, we find out what the inside is first. F of 7, well, remember that. F of 7 gives us 6. Now g of f of 7 is g of 6. 6 input, g gives us 4. F of 0, that's the inside part. F of 0 equals 8. F of 0 means f of 8. And f of 8 gives us 4. G of 3. G of 3 equals, from the table, 3 input. G of 3 gives us 5. G of 3 means G of 5. And G of 5 gives us 3. And so 3 is that answer. Now another one. We have to decide, is it easier to figure out f and g of 5? Well, for these first 4, since I'm just dividing f of 5 divided by g of 5, remember this is the same as f of negative 5 times g of negative 5. This is f of negative 5 divided by g of negative 5. Well, so these first 4, if I just find f and g of negative 5, it's just algebra of those two numbers. So let's find f of negative 5. And it's easy to forget that negative 5 and get all the wrong answers. So f of negative 5 is equal to negative 4 times negative 5 plus 4 equals 20. Negative times a negative gives a positive. 20 plus 4 equals 24. All right, so I know what f of negative 5 is. G of negative 5 is equal to 3 times negative 4 plus 1. Or negative 12 plus 1 equals 11. Be super careful on that first because you've got 4 problems that depend on using those. So make sure you got the right answer. G of negative 5. And look at that. I messed up. It's not negative 4. It's 3 times negative 5 plus 1 equals negative 15 plus 1 equals negative 14. See how easy you can mess up? 3 times negative 5 plus 1. Check again each time. Then go back and Now plug them in. F plus g at negative 5 is 24 plus negative 14, which is 10. F minus g of negative 5 is 24 minus a negative 14 equals 34. What? 38. 4 run in my brain somehow. F times g of negative 5 is 24 times negative 14. Now you can use your calculator, or you see that that is 24 times 10, 240, plus 24 times 4, which is 96. So 240 plus 96 is 336. 240. Now let's make sure 240 plus 96, 24 times 4, and that gives me 336. Carry 13, carry 1, 336. So 330, but it's a negative 336. Now f over g of negative 5, well, that's simply 24 divided by negative 14. And looks like I can factor out a 2 equals negative 12 over 7. I would be happy with that, unless they say you have to give it in decimals. I'd be happy with negative 12 over 7. If you did decimals, it'd be negative 1.7143, however far you want to go. Now, I know g of negative 5, but I have to find f of g of negative 5. So g of negative 5, we know, is negative 14. So I need to find f of negative 14. Well, that means negative f at negative 14 is equal to negative 4 times negative 14 plus 4. Right? Negative 4 times the x plus 4. Well, 4 times 10 is 40. Plus 4 times 4 is another 16. Negative times a negative gives me a positive 56. Plus 4 gives me 60. So f of g of negative 5 is 60. Now this is the different format of that same thing. I like to write it out immediately. G of f of negative 5. Figure out what negative 5 is, or what f of negative 5 is, and then feed that to g. Well, we already know what f of negative 5 is. It is 24. So this is essentially g of 24. Well, g of 24 is equal to 3 times 24 plus 1. Well, 3 times 24 is 3 times 20, 60, plus 3 times 4, 12. So that's equal to 72 plus 1 equals 73. Those, if you're not comfortable doing the math mentally, do it on a calculator. I'm just showing you the mental math just to encourage you to practice that. You'll get better at it just by practicing it. And you can always use a calculator to check. Now it's a matter of using tables to find these. So carefully check the tables. I always rewrite this. F of g at negative 4. Well, f of negative 4 is 5. Oh, sorry, g of negative 4 is negative 4. So this becomes f of negative 4, because g of negative 4 gives us negative 4. X in, g out. Now f of negative 4, negative 4 in, I get a 5 out of negative with f of negative 4. So that's a 5. g of f at negative 5. G of f, negative 5. Always rewrite, just to make it very clear, you need f of negative 5. Well, f of negative 5 is, here's negative 5 in, I get 15 out. So that means that's the same as g of 15. Well, 15 in, g gives me 5 out. F of f at negative 1. Find, or not at 1. Find f of 1. F of 1 is, here's the 1 coming in, I get a negative 4 out, so that's the same as f of negative 4. And negative 4 in, f gives me 5 out. Boy, getting 5s for everything. Are we going to get another 5? Let's find out here. G of g at negative 3. Well, g of negative 3. G of negative 3 gives me negative 3 in. G gives me negative 10. So that means it's equal to g of negative 10. Negative 10 in. G gives me negative 3 out. Now the inverse. Remember what the inverse, what we do with that? We reverse x and, well, first we state it as y equals 4x plus 7. Exchange x and the y. X equals 4y plus 7. Now solve for y. Subtract 7 from both sides. I get x minus 7 equals 4y. Now divide both sides by 4 to isolate y. X minus 7 divided by 4 equals y. That is our answer. So f of negative x equals x minus 7, or f inverse of x is x minus 7 over 4. Another inverse, same technique. We simply put y equals 1 over x plus 11. Reverse x and y. X equals 1 over y plus 11. Solve for y. Well, I see that this is a, let's see, I can multiply both sides. Let's see, what can I do here? Well, I can do the inverse of both sides. And I get 1 over x equals y plus 11. Now, subtracting 11 from both sides, I get 1 over x minus 11 equals y. See, we're trying to get y by itself, inverse both sides, and then I get 1 over x minus 11 for the solving for y. You could say, wait a minute, I see the cross products are equal. I could say, well, x times y plus 11 equals 1. Divide by x, y plus 11 equals x, or sorry, 1 over x divided by x. Subtract 11y equals 1 over x minus 11. You end up getting the same answer. So, the inverse is 1 over x minus 11. Now we're going to have to use our calculator for this one. We're simply, well, what's f? F is e to the x. Well, f of 3 is e to the third. The only way to solve that is use our calculator. So let's bring up our calculator. And I need the scientific calculator to calculate for e. And I don't have e to the x, but I have x to the y. So let's enter E, and now I do x to the y, and enter 3 for my exponent, and I get equal to, it should be up around, yeah, not 20, 20, because 3 to the third is 27, so I know it's going to be below 27, kind of just an estimate. So 20.0855, well, and they say at least 3. So it doesn't mean you have to go to at least 3, 20.0855. If you did only 3, you would round it up to 20.086. Now we're going to calculate some values here. It looks like you're going to have to, well, what are you going to have to do? F of x equals 3 to some power. Think to yourself, that power is going to be 2x minus 1. So let's first figure out what 2x minus 1 is, and then we take 3 to that power. So f of 2 is equal to 3 to the power of 2 times 2 minus 1. Well, 4 minus 1, so minus 1. 4 minus 1 is 3, so 3 to the third power is 3 times 3 is 9, times another 3 equals 27. F of 3, well, let's just go figure that out. F of 3 is 3 to the 2 times 3 minus 1, which is 6 minus 1, which is 5. So we're looking for 3 to the 5th. 27 times 3 times another 3, or just use our trusty calculator. And we enter 3, x to the y, 3 for the y equals, oh, sorry, not 3 to the third. Enter 3, x to the y. 5 is my exponent. 243. Now we have one financial formula. This is one that we have memorized right now because it's fresh in our minds. We'll be looking it up in the future, but the accumulated or final value is equal to my principal times 1 plus, let's see, what is it? The interest, 2.5%, remember that is equal to 0.025. Don't forget that, 0.025 divided by the number of times per year that I am compounding it quarterly. So that means 4 times a year to the power of how many times per year is compounded? 4 times the number of years, 7. So that's 28. So let's calculate this. Oh, and my principal is 5,600. So let's do this part, take it to the 28th power, and then multiply it by 5,600. So 1 plus 0.025 divided by 4. Alright, so calculator. 1 plus 0.025 divided by 4 equals, 1 and a plus a very small amount. Take that to the power, y to the 28th power, y to the x, now exponent of 28. So it's just a little bit more than 1, but when you take it to a large power, it becomes a little bigger. And what do we multiply that by? Our initial investment value, 5,600. So multiply by 5,600 and I get 6667.35. And round that up to 2 decimal places. 6667.35. And write that in my solution. 6667.35. So what did I get? I gained about $1,000 for 7 years. Not a very great interest rate, but that might be your mortgage rate. So you end up paying for your mortgage, 7-year mortgage, pay a little bit more, $1,000 more for your $5,600 house. Usually when it's a small interest rate, it's hoping something you're paying. You want to pay low interest rates, you want to earn high interest rates. Now, we're just remembering the definition of logarithm. First thing I do when I'm thinking logarithms, think of that basic one, log. We know that log base 10 of 100 equals 2. There's 2 zeros in 100. Log base 10 of 100 says count the zeros. Well, now I can remember that's true for any number. This means 10 squared equals 100. And remember that little 10, that base to that power gives us that, and that's in our parentheses. So we see that. We automatically see q to that power equals c. Q to the a power equals c. Q. Make sure that's clearly a q. It's easy for a's and q's to look the same, so that's a poor choice of letters by the authors of the test. I'm not sure there's much you can do. I think the system kind of randomly picks a letter of the alphabet. Now we're going the other direction. And again, we can write that out. Log base a of x equals y means a to the y equals x. A to the y equals x. Well, I've got 4 to the v equals w. And it's going to look like that. 4 to the v equals w. So let's just write out log something to something equals something. Well, 4 to the v equals w. Think through that, and then 4 to the v equals w. Whatever way helps you to know what that looks like. As if you do enough, you'll recognize it. But that's a perfectly fine way. Just write down that equation. Now with the rest of these are simply using the rules of logarithms. Remember that when you add logarithms, it's like multiplying these two things. So this becomes log of 3 times 9 base 5 of 3 times 9, or log of 27 base 5. Just going the other direction, rules of multiplication. Rules of division, well, that's the log base 2. Remember, the bases have to be the same. Yep, base 2 of 7 divided by z. Now that's why we do the line. That's why I do the line with between the and on the z, because it looks so much like a 2. So there it is, log base 2 of 7 over z. Another little more complicated problem. It's combining, adding logs, but before we add them, we recognize when you're multiplying a log, that's the same as the log base 4 of a to that power. So let's put that first one into exponent form first. 2 log 4 a is equal to log base 4 of a squared. And then it's log base 4 of y to the 6. Now we can do the law of multiplication, and that's our final answer. There's nothing else to do. We can say that that's log equal to log base 4 a squared times y to the 6. Do it in steps. just to make sure you get it right. There's a similar one, except going the other direction. Somewhere difference with no more exponents around. Well, first we'll do the rule of multiplications. That's log x to the 13th plus log z to the 12th. And now the rule of exponents, that's 13 log x plus 12 log z. We got rid of our exponents. Remember, with logs, the exponent comes out to the front. And that gives us that. No more to break apart. Sum of two logs. And we're going to use the division rule for our final problem. I know it's going to be equal to log base 3 of y to the third minus, because I'm dividing instead of multiplying, log base 3 of x to the 7th. Now apply log of exponents. Those come out to the front. And I get 3 log base 3 of y minus 7 log base 3 of x. That is the solution to version 2 of the quiz. And good job. Many of you, I think most, if not everyone, did better.